Welcome back to Hall 6, and I'm delighted to welcome Nicolas to give us his talk on pragmatically evolving APIs. He's a developer advocate for API 6 from the Apache Foundation, and hopefully he's going to be showing us a few tricks and trade when it comes to the API 6 project and all things API, which I know I'm particularly close to my heart. One thing I did ask Nicola up front was there anything he'd like us to know that has nothing to do with his talk? And it turns out he has no formal IT education. I love the fact that we are such an egalitarian profession that your background doesn't really matter so long as you've got the experience to back it all up. So without further ado, hopefully we can hand over to Nicolas' talk and we can learn a bit more about API 6.
Hi folks, thanks to be here for this talk about evolving your API, a step-by-step approach. I'm Nicolas Fränkel. I've been working in IT for more than 20 years now. I held a lot of different technical roles, from developer to solution architect, and since a couple of years I decided to switch to developer advocacy, though I think I'm still a developer. Regarding this talk, you probably are interested in APIs because you actually had to develop one. And the first time or the first couple of times, you are very focused on very specific things like modeling the right entities or trying to understand what is REST, what is RESTful, and reading Roy Fielding's writing and everything that has been written on REST before. Just a note, I will use the term API for HTTP APIs, and I won't delve into the specifics of REST because there is a lot of debate. So just to be clear, it's not about REST. You can use this talk regardless whether you have been doing REST or not. Anyway, so you were focused on those topics, and on top of that, you had a project with a deadline, and you didn't think about some stuff that was not very important at the time. But when your business comes to you and say, hey, we want to write a V2, then it becomes important. How do you manage to evolve from V1 to V2? And if you didn't plan ahead, you probably have this kind of reaction. So my idea in this talk is to give you a couple of tips and tricks so that when you write a V1 and your business comes to write to ask you to evolve to a V2, you don't have this kind of reaction and you can handle it more peacefully. So this is probably your initial situation. You have an upstream. Here I'm using the word upstream for reason that I will explain later. You can think about as an upstream as a regular web app or application or whatever. And you have a couple of endpoints that you expose over the internet. And I'm telling you, hey, everything will be solved if you put an API gateway between your upstream and your clients. That's easy. Sounds too good to be true, especially since now you realize that you probably already have something that sits in between, and that something is called a reverse proxy. And I'm telling you, no, you should use an API gateway. So before I delve into how, let me give you the reason why an API gateway can help and why it's different from a reverse proxy. For that, we need to go back a bit. So as I mentioned, I've been working in IT for a long time, but before even I worked in IT, I created my internet website. I started to use the internet before 2000, which is for most of you probably very, very long. So my first website At the time, we had HTML, and I learned HTML not by reading books about HTML. There was no Google search at the time. There was no Google. Google just started just a bit afterwards, or at least I came to know it a bit after I started. I browsed directories, Alta Vista at the time. So I learned HTML by reading the web page, by looking at the source itself. We already had images. That was nice. We had a lot of images to make it look much nicer. We also had audio file, MIDI audio file. So every time you browse the website, you could like play this MIDI file. It was automated. You couldn't stop it. That was horrible user experience, but of course we did it because we could. There was no CSS, so to create your buttons, you had this bevel effect with table, really great developer experience, and I let you to judge whether no JavaScript was a good or bad idea. Anyway, that's how we managed. At the time, I didn't think about it, but there was a web server. And the web server, in this case, was made to serve static content. So HTML pages, images, MIDI files, everything was static. But some people decided it was not enough. We wanted to have dynamic content. Of course, we wanted to have dynamic content to display the date and the time, which was completely useless. Again, horrible user experience. But sometimes you wanted to do like real interesting stuff, like a last updated timestamp, which was useful to you. You could see that the page hadn't been updated in ages, or it was very fresh. And we started with Perl scripts because Perl was available on many Linux systems at the time. The problem with Perl is, well, first you had to know Perl, and then you had to like write something in Perl to generate something in HTML, which was not that great regarding maintenance. So somebody decided, hey, we can do better. Perhaps we can write HTML and add a couple of tags. And when the server serves the page, it just like outputs the regular static content. And when there is these special tags, then it calls some routine. And it was the beginning of PHP, personal home page. And that was really, really great. Everybody was happy. And it was so great that actually the World Wide Web starting to see an increase. Companies, not regular people doing their own personal website, regular companies wanted to have their own website to look good, to have another channel of communication with their customers. And as a personal user, if your site is down, that's not great, but you can survive. If you are a company, you want your image to be spotless. So you want your site to be up all the time. And that's when the web server started to have different features, not only serve static content or dynamic content, but we had another row of web server in front to do some redundancy. Like, for example, for load balancing, if a node was down, we would direct it to a node that was up. And of course, the web grew and grew. And before you had a couple of nodes serving contents, and the content was all the same. But now we had extranet and intranet and internet. So all the nodes were not similar anymore. So these another layer of web server, they had also to do routing, saying, oh, okay, this person wants to access the extranet is on those two nodes, so I will direct it to one of those two nodes and not to the other nodes that serve, I don't know, the internet. And so that's the evolution of the web server. To serve static content, then to serve dynamic content, then to do load balancing, then to do routing. And actually, this layer of web server, this front layer, is known as a reverse proxy. It becomes the single point of entry to do everything. And once, as an architect, you see a single point of entry, you start to push additional capabilities. You can have authentication, you can have caching, you can have rate limiting, you can have lots of different capabilities because you have a single entry point. On another side, we also started to exchange data. So at the beginning, to exchange data with another company, we sent a file through FTP. On the other side, there was a bad job watching the folder, and every hour or every day or every time, it would check the contents of the folder, would manage the content of the file, and then rename the file to done, for example. That's good when it's asynchronous, but when you want to have synchronous communication, you need to find another way. And the problem is that companies might and probably have different tech stacks. So you cannot rely on Java or .NET or whatever specific protocols. And the only brick that is available across all tech stacks is HTTP. So that's the reason for APIs. We want to exchange data in a format that is available to all tech stacks. And that's where comes the difference with reverse proxy. An API gateway is a specialized reverse proxy. It should be able to do everything a reverse proxy is able to do, but with dedicated features only for APIs. For example, I mentioned rate limiting. That's what a reverse proxy is supposed to be able to do, because you want to prevent denial of service attacks, distributed, DDoS. But with APIs, you just don't want to do only that, because if you limit the rate, you will limit everybody at the same rate. And with APIs, you might have specific offers to say, hey, you pay this much money, so you are able to use this limit, and you pay this much more money, so you are able to use a much higher limit. While it's possible to code this into a reverse proxy, you have to understand that reverse proxy were designed at a time where on-the-fly configuration change were not an issue. You just put a static web page and saying, hey, we are down for a few hours, and that was okay. Nowadays, it's not possible anymore. Every site, every app should be up all the time. This static web page, we old IT people, we understand about it, but regular people, they see Google, they see Amazon, they see Facebook. Those websites are never down, and other sites, for this reason, cannot be down, even if we are not competing on the same scale. So we need to be able to change the configuration on the fly so that we can update the business logic on the fly without any downtime. And in my opinion, that's what makes the difference between an API gateway and a reverse proxy, and the fact that it's focused on API capabilities. There are a couple of API gateways that you can install on-premise. There are lots of cloud ones as well. I work on the Apache API 6 project, as you can see from my t-shirt. There are others. In my demo, I will use Apache API 6. I assume others can do the same. Just 2 words about Apache API 6. It's an Apache project, as its name implies, and it has become a top-level project in 2020. So you can visit api6.apache.org. It's built on the Nginx reverse proxy, which is a very solid reverse proxy. Then on top, you have OpenResty. As I mentioned, the problem of like regular reverse proxies is you need to switch them down to change the configuration. So OpenResty is a Lua layer that allows you to script the change of configuration of Nginx on the fly. Then you have like the API 6 core layer, and then you've got a couple of plugins that are available out of the box. So you can take from the out of the box plugins catalog, or you can create your own. Anyway, now that we know about it, we can come back to how to do it. So as I mentioned, everything can be solved with an API gateway. I will have a demo. Let's do it. So as I mentioned, I will be using Apache API 6. Here I've created a Docker Compose file because it makes my life so much easier. I have the Apache API 6 image. API 6 relies on etcd, which is a key value distributed data store to store its configuration. So I have it as well. Then I have dashboard, so you can like see and change the configuration visually. I have Prometheus because I want to scrap the metrics. I want Grafana because I want to monitor the metrics. And then I have the old and the new API. Of course, normally I should first have the old API and then add the new API. But for like the reason, because I'm using Docker Compose, I have everything in one go. So let's start it. Compose up. I have downloaded everything beforehand, so it should start very, very quickly. I have just like a migration of Grafana, and then because the new and the old API are in on the JVM, it might take a bit of time, but normally it should be set very, very fast. So the new API and the old API are pretty similar, as you can see. I have exposed both directly, so you don't need to go through the API gateway just to check how they work. Normally you should hide them. They shouldn't be available outside the API gateway. And it should be okay. Completed initialization, so we can perhaps try it. Curl localhost 8081/hello. Let's check. Yes, it works. That's my old API, and the new version is obviously much, much better. So the idea is, how do we move from one API to the other? As I mentioned, the API gateway should help you. So we can try to call it, and we got a 404. The reason for that is that at the beginning, the API gateway is fresh. It has not been configured. Can configure Apache API 6 through an API call. So we can create our routes directly through an API call. I've prepared everything. So here you see a script. I don't assume you have curl installed on your system. So if you don't have curl, here I'm using a Docker curl image, and I make sure that we are using the same network as a Docker Compose. So we can call this route, which is the route endpoint, to create a new route. Because it's a sensitive operation, you don't want everybody to be able to change your API gateway configuration. Here you need to pass an API key. I'm using the default one because I didn't change it. Of course, in production, you need to change it to something more secure. And the payload is the following. So you can put a name, which is optional. And if the route, so this route will be invoked if it matches this method or and any of those like path. So if I send a GET request with hello or hello whatever, then it will match this route, and the gateway will forward the call to this upstream, which at the moment is the old API. And because I want everything to be monitored, I add a dedicated plugin. So if I run it, and if I call now same routes, now Apache API 6 knows about the route and forward it to the regular old API. Good. Now we are back at square one. We made everything working again. It's time to do something more interesting. Now we want to version the API, to start versioning, because at the beginning, as I mentioned, we had no time to think about it. It was unversioned. We want to start versioning. There are multiple ways to version an API. You can do it path-based. That's what I will be using in the demo because it's the most visual one. You can use it query-based, like having an additional query parameter, or you can do it header-based. Everything is supported by Apache API 6, but as I mentioned, it's more visual to have the path. So I want to create a version route. I could do like previously, create a route in one go, but I can notice that there is this upstream abstraction that will be I will be reusing over and over again. And so I want to create a dedicated upstream for that. And that's good because Apache API 6 allows me creating it. So I have another endpoint called upstreams, and I will create the upstream and say, okay, I will create an upstream for the old API. And then I do the same with the plugin configuration. I could create a dedicated plugin configuration, or I can create a global rule. So with a dedicated configuration, I need to reference it every time. If I forget, I won't be able to benefit from it. With a global rule, it will be like on every route that I create by default. So here, that's what I want to do. I want to create a monitoring plugin. No, so in this case, Prometheus. So I want to create a global rule. So now I create the global rule. And the final step is to create the version route. So here, I create a new route with ID 2, and I can reference the upstream ID that I created previously. And also I will reference a plugin ID. The plugin ID is the following, and it's a dedicated plugin config. And the reason for this is I will send v1/hello to the API gateway. If I don't do anything, the API gateway will forward v1/hello to the upstream. And v1/hello, the upstream doesn't know about it. The upstream only knows about hello. So I need to remove the v1 prefix. And for this, I have a plugin called proxy rewrite. It's a simple regex query. I will say, hey, when on this route I receive v1/something, just remove v1 and just use something. So we can apply it. So now if we curl with v1, we've got the same results. Now we have two routes. And it's time for me to show you the Apache API 6 dashboard. I've told you that you can manage the configuration of Apache API 6 with APIs. There is also a UI for that, so we can have the dashboard. I can check the routes. Of course, here I'm using, again, the default admin stuff. You shouldn't, you should change it. And we can see that we have created two routes already. The old API unversion route and the old API version route. You can change the configuration also here on the fly. You can check the JSON and you can change stuff. Here, let's say to old API changed. submit, and here you can see it's changed automatically on the fly. Here it's just for optional data, but of course you can change it for regular data. Here you can have the upstream as well. And yes, this is the upstream that I created. Okay, let's go a bit further. If we have an unversion endpoint and a version endpoint, there is a high chance people will keep using both, or even worse, even the unversion one, because there are less characters to type. So we want to tell people, hey, please stop using the unversion endpoint, you need to use the version one. But at the moment, we don't know who our users are because we didn't think about making them register. So there is only one way to do it, is to redirect those people to the correct URLs. If they are using the unversion endpoint, we will redirect them. So for that, I will use like the first route, the unversion one, and I will patch it with a plugin which is called redirect. It does exactly what it's supposed to say. It redirects people with a 301 to the URL appended with prefixed with v1. So let's run it. And now, if we use the unversion endpoint, and I will be verbose about it, it tells me, hey, it has moved permanently and you need to use v1/hello, which is very, very nice. Or if we are using like automated follow, then it does what it's supposed to do. And that's very important now from a user point of view, that you always monitor your API usage from the client point of view. Because either you will have like bunches of 301 and it won't work anymore, but at least you will know about it, but it's better to monitor in any case. Or it will still work if you are using automated follow, but you will have twice the number of requests, which can be a high burden of infrastructure. So even as an API consumer, you should monitor your usage. Great, now that's good, but I told you just before, the problem is now we don't know our users. So how do we know our users? Well, there isn't much choice. Actually, I can ask you to register, but you probably won't do it because you don't want to give away your email, you don't want to get those marketing emails, you don't want to get pestered every now and then. And I'm like you, I don't want to give my email because I don't want to receive this kind of, hey, we have a new product or whatever. But as developers, we like free stuff. So we need to provide an incentive for people to register and of course not pester them with marketing emails. So in this case, what I can do is I can tell people, hey, now we will rate limit you unless you register. And it works. So in this case, I will create my own plugin because I've so far used only out-of-the-box plugins, but none of the plugins that are available out of the box just do exactly this kind of stuff. So I've created my own plugin. It's written in Lua. I won't delve into it. It's just like I'm not a Lua developer myself. What I did is I just copy-pasted an existing plugin, the rate limiting plugin, and I said, okay, I will just add like a couple of lines to say, hey, if I'm registered, it's fine. So here I have this call limitation, call it unauthorized limits. And now if I call, so it's on the v1, if I call it multiple times, it tells me I should register. How you register is outside of the scope of this talk. Now, regarding Apache API 6 and the code I'm using, I just say, hey, if there is a dedicated user, then I'm authenticated and I will be able to bypass the limits. So how to create this user? This user in Apache API 6 semantics is called a consumer. And I'm using, so the consumer's endpoint to create a new consumer, I'm using the most simple one, which is key auth. Basically, it tells if I pass an API key with value, a header with name API key and value my key, then I will be recognized, authenticated as John Doe, and my plugin will let me pass because I'm authenticated. Let's try it. So now I can curl and pass the header API key, my key, and I will just copy paste because I'm super lazy. And now I can call it to my heart's content. Of course, it's just a demo. You have JWT token, you have OpenID Connect, you have lots and lots of ways to get authenticated. Do whatever strike your fancy is just an example. The next step is to test before deploying. And probably you are doing unit testing, you are doing integration testing, but at the end of the day, you will need to deploy to production. So you need to test in production anyway, you are not sure about it. Most people would do canary release, which is my next step. But before doing canary release, we can be smart. The first thing that we can do is just like duplicate the production load, send it to both the upstream v1 and the upstream v2, and check that the response code from the upstream v2 look exactly the same as the response code from the upstream v1. If they have the same curve, it probably means that they behave the same and we have more confidence into deploying. That's where comes a plugin called Proxy Rewrite and Proxy Mirror. That's where comes a plugin called Proxy Mirror. So basically, Proxy Mirror will actually like send the same load as the production load to another upstream. In this case, this is this new upstream. Now I need to tell you about something important. Plugins in Apache API 6, they are run in order. And obviously, a plugin with a higher order priority will run before a plugin with a lower plugin priority. Thing is, in some cases, you don't want this order. You want a very specific order. And this is my case right now. First, I want to execute the proxy rewrite to remove the v1 prefix. And then I want to mirror the load and to send it to both upstreams. By default, it's not the case. So I need to reorder the plugins a bit by setting the priority that I want. This is what I'm doing right now. So now I can like run this plugin. I will curl a couple of times just to have some data. And remember, now I have unlimited calls because I'm authenticated as John Doe. And now we can check on Grafana if the curves, they have the same like similarities. I'm using the default Grafana dashboard for Apache API 6. What I just did is I added like two widgets, like those two widgets, one for the old API, one for the new API. and I can check that they have the same curve. So of course, at the beginning, they hadn't the same curve because it didn't exist. But here we can see that here I have the same way. Of course, they are not on the same scale, so you need to compare what is comparable. Let's do some more calls. So normally it should like follow the same trend. So it should get back here. Good. At this point, everything is good. They both look the same. The only thing is that the upstream V2, it doesn't return the response. It's discarded. So finally, we need to do some canary release. So for canary release, I need to create my upstream V2 that I didn't create before. And well, there are multiple ways to do canary release. The first way to do canary release is like, let's take a small percentage. You can do through geographical location. You can do through a dedicated header. You can do through many different ways. Here, I'm using very simple for the demo. I will redirect half the calls to the new API and half the call I will direct to the old API. And I need to remove the proxy mirror as well because I'm using patch. So I will remove the proxy mirror and I will use the traffic split. Yep. And now when I'm calling V1, actually half of the calls will be directed to V2. Great. I'm nearly at the end. The last problem that I need to address is now I have V1 and V2, and probably afterwards I will have V3. If you have worked in product, you know that the more endpoints and more versions you have, the more maintenance effort you will have. So you need to deprecate some of the older endpoints. And for that, there is no proven solution. The only thing that I found is an IETF draft that tells about the deprecation header. So you would tell in the deprecation header either a date at which time in the future your endpoint will be deprecated or a boolean which says is deprecated. In the demo, I'm using a boolean, which of course you shouldn't do because you want to tell your users ahead of time. And then you have a link header that points to the new resource. And finally, after deprecation, there is like end of life. And there is an optional sunset header that tells at which point in the future you will completely undeploy this endpoint. This one is easy. It's just adding headers into your response. So I create like the route itself with every plugin, the V2 route. And now I can like deprecate the V1 route. As I mentioned, that's an additional plugin. I don't need the traffic split anymore. I don't want to redirect something to the V2 because V2 works as expected. I have the response rewrite and I will add the headers. As I mentioned, I'm using a boolean, which you shouldn't do, and I'm using the link. And here I'm using the Nginx variable so that it's very dynamic. So if I run this, and now I can use the V1, you see I'm not redirected anymore to a V2 version. And if I'm asking it to be verbose, it tells me, hey, deprecation equals true, and the link is this one. You shouldn't use the V1, you should use the V2, so that's what I missed. I should have directed to the V2. And normally on the V2, everything works as expected. And here, always, I will have V2 answering. Great. And the last step is the time for the V3. And I believe if you implemented all the steps that I've shown you in this demo, it should be much, much easier. Like the next step is actually just to enjoy. I thank you a lot for your attention. You can read my blog. You can follow me on Mastodon or on Twitter. If you are interested about the code, everything is on GitHub. I keep it up to date regularly, so please have a look every now and then. Don't fork it. You can store it, but don't fork it, because I force push every time to have the latest version only. And if I got you interested in Apache API 6, well, please have a look at our website. Thanks again for your attention, and have a nice day. I cannot hear you.
Yeah, thank you very much, Nicolas. Fantastic. As someone who has a background in web APIs and who loves HA proxy and reverse proxies in general, you might just have started to open up my eyes to the benefits of API gateways, which is absolutely fantastic. So, you know, just looking at what you've gone over, there are a few kind of general things that I've had to solve in the past when it's come to reverse proxies. And one of those is HTTPS termination. And I just wondered if there was anything you could mention about API 6 termination and maybe passing some of the certificate information down to the lower levels.
I will be quick. I've written a blog post about it called MTLS Everywhere. So not only about TLS, but mutual TLS. I will send you the link. You can like spread it to the audience, and it will be much easier. But yeah, everything is possible.
Sure.
And also, sorry, I mentioned that you can store you generally store the configuration in etcd. So there is also a way to mutually authenticate from etcd to API 6 to API 6 to etcd, so that everything is like completely secure.
Fantastic. And my final question is, can you distribute API 6? So can you have a horizontally scaled architecture with it?
Yes, but at some point you will probably need an IP sprayer or something that would distribute the loads to API 6. In that case, what I would recommend is to have like not the configuration not stored in etcd, but in like regular files. Then to have GitOps, and then basically your like instances are completely stateless, and then it makes the work so much easier. But yes, you can do it. It's not an issue at all.
Fantastic. Well, thank you very much, Nicolas. Terribly sorry for the technical difficulties, but thank you very much for sticking with it. And we'll catch you for our next talk here in Hall 6. Bye-bye.
Have a good day. Bye-bye. Thanks for having me.
This is all we got. Remember the revolution in our minds. This is all we got. Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to say we're sorry. We don't need to worship ever stars. We don't need to say we're